Hello dear students, this is Nayab, your maths teacher, and today we are learning linear graphs and simultaneous linear equations, which is chapter 2 of Syllabus D book 2. And today we are going to solve exercise 2b and partially 2c. Exercise 2b, question 1. The graph shows Carol's journey when he visited a friend in town C. During the journey, he stopped for breakfast at a cafeteria, after which he continued to drive to town C. So the question is, at what time did he leave home? As you can see that we have a graph here, and on y-axis we have distance that Carol traveled, and on x-axis we have time, and it is a 24-hour clock. So we can read as 1000, 1030, 1100, 1130 hours, and 1200 hours. And here we have got distance, and each interval is divided by 10. That means 1 centimeter is equals to 10 units here. Now he started his journey at this point, which is 0. And at this stage, the time is, as you can see, it is 1000 hours. Now the second question is, how far did he travel before he reached the cafeteria? So he started traveling here, then he stopped. As you can see that there is no vertical slope here. So he stopped here. So how far did he reach? If this is the cafeteria, point A. So let's match this with the y-axis. We can say that he reached or covered a distance of 50 kilometers. Then find the gradient of OA, find the gradient of this slope. As you know that the gradient can be found with the formula rise upon run. And if this is the slope OA, so we have to make a right angle triangle here. So we have to see what is the rise. Now on y-axis, this is basically kilometers and each unit is 10. So this is 10, 20, 30, 40, 50. So the rise is 50 steps. And the run is on the y-axis, and on run we have got hours. So let's see what is the difference between these two. This is 1000 hours and this is 1100 hours. In 12-hour clock, we can say this is actually 10 a.m. and 11 a.m. So difference is 1 hour from 1000 hours, and between 1000 hours and 1100 hours, the distance, the time difference is 1 hour. So let's use the formula rise upon run, that is the gradient, and gradient is initialized as m. Okay, so you can say m is equals to rise upon run is equals to, okay, so we have got 50 here, 10, 20, 30, 40, 50 upon 1. So distance upon per unit time is basically speed. So his speed was basically 50 kilometers per hour, or you can say the gradient of the slope is 50. Now, as you know that the gradient of a horizontal line, because it doesn't move anywhere, it doesn't rise anywhere, so it's 0 basically. Okay, this slope of this, it is not rising anywhere, it is only running, and it is running for about 30 minutes or half hour. So rise is 0 because it's not moving anywhere. This line, horizontal line, doesn't move anywhere. So rise is 0. And run is half hour, which is 0.5. So when you divide any number with 0 with any number, you get a 0. So if you see the discussions, investigations of this chapter, you will find that the slope of a horizontal line is always 0. and the slope of a vertical line is undefined. Okay, now let's go to this. What is the slope of this BC line? So again, we need to make a right angle triangle. Let's make it. And now we have to calculate what is the rise. 10, 20, 30. So rise is 30. And run is 1130, 1200. So the difference is half hour, which is 0.5. So rise upon run, slope is rise upon run, is equals to 30. Rise is 30, 10, 20, 30. Each represents 10 units. 10, 20, 30. Over run is this, which is half hour. This minus this. Half hour. So 30 divided by 0.5 is 60. Right? Now, having said this, kindly pause the video and solve question number 2 from your Syllabus D book 2 from exercise 2B. That will give you additional practice. Once done, you can resume the video. Now let's go to the next exercise, which is exercise 2C. And here we have a graph. This is the exact picture of the question which is in the reader. So we have what? X-axis and Y-axis. And on these two, we have two lines, line 1 and line 2. And we have to write an equation of these two horizontal lines. And if the line is horizontal, the equation will always begin with y. Y is equals to something. If it is horizontal, the equation will begin with y. Y is equals to something. Now, what is that something? Something is that point on which this line is intersecting. Basically, the intersecting point. Here, for example, the intersecting point of line 1 is 6 on the y-axis. So the equation of this line will be y is equals to 6. And therefore, the equation of this line 2 will be y is equals to minus 2. So line 1, equation of line 1 is y is equals to 6 because this line is meeting the y-axis at 6. Similarly, the equation of line 2 is y is equals to minus 2. Remember, if there's a horizontal line, the equation will begin with y. And if it is a vertical line, the equation will begin with x. Good. Now, once said, now we are given the equations. Can we draw the lines here? So if y is equals to minus 3, if this is our equation, how will we draw on the graph? So we have to really see where will our horizontal line meet the y-axis at minus 3, which is here. So probably this will be the first line. And where our horizontal line will meet the y-axis as 3.5. So it will be in between 3 and 4 somewhere here. So let's draw that one. There you go. Wasn't it simple? So if the equation is starting with y, you'll get a horizontal line. And you have to see where that horizontal line will meet the y-axis at which point. Let's see the second question. Here we have another graph. So we have to write the equation of line 1 and line 2. Now you see that line 1 is a vertical line and line 2 is also a vertical line. And if the line is vertical, the equation will start with x. So where is it meeting? What is the intersection point here of line 1? It is half or 0.5. So let's write the equation. x is equals to 0.5. And so where's the intersection point here of line 2? -2. So the equation for line 2 will be x is equals to -2. Simple. Now, if we are given the equation, can we draw two vertical lines? If x is equals to 1, so we have to find where 1 is. 1 is here. That's just intersection point. And so we'll draw a vertical line where it will meet at 1 intersection point. That's intercept. Good. Okay. And x is equals to -2.5. So intersection point is 2.5. And you can call it intercept. So let's find 2.5. -2.5. It will be somewhere here. And since the equation is starting with x, it will give you a vertical line there. Okay, so this was today's lesson. Kindly practice, and practice makes perfect. Please solve the question that is given in the book, which is question number 2 of exercise 2b, and we'll solve the rest of the exercises now, starting from 2d in the next lecture. And I hope to see you again. So take care of yourself and see you soon.